This is Geometry Lesson 9-1, and it's titled Using Ratios and Proportions. And it starts on page 350 in your print text, and in Braille volume 33, it starts on page 350. There's not a lot of graphics in this section because it's just kind of a review of using ratios, rates, and proportions that you've learned since middle school and practiced quite a bit probably in pre-algebra days and algebra days. So we're going to do a review of that in this section and do some practice with it. So on page 350 it starts out reminding you what a ratio is by using an example about some garbage in the United States. It says, in 2000, about 180 million tons of solid waste was created in the United States. Paper made up about 72 million tons of this waste. The ratio of paper waste to total solid waste is 72 to 180. This ratio can be written in the following ways. So they write it out 72 with the word TO, 72 to 180. They write it out with a colon in print, and in Braille they use the Nemeth colon, which means you would do a number sign, 72, a space, then a .5, then a .2, then a space, then a number sign, 180, because it's a comparison symbol like an equal sign. Then they also write it in fractional form, and that's what we do a lot in mathematics with our ratios, is to write them in fractional form. So 72 over 180, or in Braille, simple fraction open, 72/180, simple fraction close. Also, you can write it as division, 72 divided by 180, because that's what it is. It's comparing two numbers by division. And that's what the definition of a ratio is in the next set of information. It says words. A ratio is a comparison of two numbers by division. In symbols, A to B, A colon B, A over B, or A divided by B, where B does not equal 0. The reason why we can't have B not equaling 0 is you can't divide by 0, that's undefined. Goes on to say that all ratios should be written in simplest form. Because all fractions can be written as decimals, it's sometimes useful to express ratios in decimal form. So in example 1, we practice it with 45 is to 340. So write it in fraction form, 45 over 340. And we can divide both of those by a common factor of 5. To get it into simplest form, it works. It is a fraction, so same rules of fractions. And 45 divided by 5 is 9, and 340 divided by 5 is 68, and that's as far as we can go. So that's the simplest form of the ratio 45 to 340, 9 to 68. The reason why we put it in simplest forms is, it's the key word simple. It's simpler to understand when it's reduced down to its lowest terms. There's another one that's in words in example 2. It says 6 days to 2 TWO weeks. Now there's a little bit of trickery in this particular ratio. We need to notice that we have days and weeks, and if you can change the units of one of your numbers to be a common unit of the other, you need to do so. So we could change the 2 weeks to days, and we'd actually have 6 days to 14 days, right? 7 days in a week. You could also change the days to a week. 6 days would be 6/7 of a week, but it's a little easier to deal with 6 days to 14 days mathematically. You can still do it with 6/7, but you got to do a little more work. So then we would write 6 over 14. Both of those are divisible by 2. Both 6 and 14 have a greatest common factor of 2, so we get it down to 3 to 7. So for every 3 days, there's 7 days. For every 3 weeks, there's 7 weeks. Okay. In the your turn, they have you try 18 to 24. So 18 over 24. What could we divide both 18 by and 24 by? Some students start right off with 2. That's fine. Let's do 2. And we see that we get 9 to 12. You should notice that 9 to 12 is not simplest form. They both could be divisible by 3. So we would have 3 to 4. Some students see 6 right away, that 6 is the greatest common factor of 18 and 24. You could divide both 18 and 24 by 6 and you'll get to the same place, 3 to 4. Whatever route you take, remember you can take the side streets if you want to, if that's the route you know, and you do divided by 2 and then divided by 3, or you can take the freeway. You can do it with the greatest common factor 6. Just do something and keep moving. All right, the next ratio to try is 10 kilometers to 20,000 meters. So we can change either the kilometers to meters or the meters to kilometers. Kilo means 1,000. There's 1,000 meters in a kilometer. So we could change this to 10,000 meters to 20,000 meters, or we could change it to 10 kilometers to 20 kilometers. You're going to end up at the same place. If you have 10,000 over 20,000, that cancels and reduces by 10,000 each, and we end up with 1 to 2. Or you could do 10 kilometers over 20 kilometers. And you divide both by 10, and you end up with 1 to 2. Just change one unit to the other, if possible, before you simplify. So now we're on to page 351. We're going to discuss proportions. At the very top of page 351, it gives the definition of a proportion. It says a proportion is an equation that shows two equivalent ratios. And they show the ratio of 20 is to 30 as, that's the equal sign, 2 is to 3. And you should see, yes, you could simplify these by not getting rid of the zeros or dividing by 10. These are the same. A proportion is building up your fraction or reducing your fraction. And every proportion has two cross products. That means we can cross multiply. And that's really cool because if we do that, we're going to see that the cross products equal. And so in this proportion, the term 20 and times 3, so the numerator of the first fraction times the denominator of the second fraction, 20 times 3, that's 60. And then we go the other way. We go the denominator from the first fraction times the numerator of the second fraction, and we get 30 times 2, which is 60. And 60 equals 60, so that shows that these cross products are equal, therefore the proportions are equal. And this is called the extremes, the 20 times the 3, the outers. If you're in Braille, it's the very first number and then the very last number. Those are the extremes. You multiply those. And then the means on Braille, that's the two middle numbers, the second number and the third number. And in print, it's the middle numbers, but if we write them in ratio form, it's the denominator times the numerator. The cross products, if they equal, then it's proportionate. So it says theorem 9-1 puts that in official mathy language for any numbers, A and C, and any non-zero numbers, B and D. You have to say non-zero because you can't divide by 0. A over B is equal to C over D. Then AD equals BC. In other words, we can cross multiply A times D and B times C. And we can do the converse. Likewise, if AD equals BC, then we know that A over B equals D over C, or C over D, excuse me, C over D. Do them in the right order. There we go. All right, and then they give an example in numbers. 5 over 10 equals 1/2. Then 5 times 2 and 10 times 1, they equal each other. 10 equals 10. And if you have 5 times 2 equals 10 over 1, then you have 5 over the 10, the first two numbers, equals the second two numbers. And you do it in reverse order. Instead of saying 2 over 1, you say 1 over 2. And it also reminds you that you can use cross products to solve equations in a proportion form. So we've got an algebra link. So we're at example 3 in the middle of page 351. It says to solve 15 over 35, 15 is to 35 as 3 is to 2x plus 1. So we can cross multiply. We do the 15 times the 2x plus 1. And remember, you have to use the distributive property. The 15 needs to multiply the entire quantity of 2x plus 1. So 15 times 2x is 30x. And 15 times 1 is 15. And then that equals the cross product of 35 times 3, which is 105. Now you have just a two-step equation to solve. You've got 30x plus 15 equals 105. You need to subtract 15 from both sides using your subtraction property of equality to undo the plus 15. And you have 30x equals 90. Then you divide both sides by 30 using your division property of equality, and x equals 3. And if you want to check it, you plug the 3 back in to your original equation. You'd have 2 times 3 is 6, plus 1 is 7. 7 times 15 is 105, and 35 times 3 is 105. And it takes you through that proof process, the original equation and the cross product, and using your distributive property, subtraction property of equality, division property of equality, and simplifying and checking. Okay. So you need to be good at practicing those. You'll most likely see those on an exam. Let's try the your turn on page 352 where it says solve. It's a little letter C. It says solve 3 over b equals 15 over 60. So you set it up. You multiply your extremes, your outsides in Braille, 3 times 60. Numerator times denominator in print. That would be 180. That equals 15 times b, which is 15b. How do you get b by itself? If it's being multiplied, we need to undo it with division. And 180, we're going to divide 15 on both sides, and 180 divided by 15, b equals 12. Pretty basic to find just a variable by itself. The next your turn puts an algebraic expression in the mix. Little letter D says solve x minus 2 over 4 equals 4 over 8. So we have x minus 2 times 8. Know that your 8 needs to multiply the x and the minus 2. So we have 8x minus 16. And then 4 times 4, so that equals 16. 8x minus 16 equals 16. We want to undo the minus 16, so we're going to add 16 to both sides. 8x is going to equal 32. You're going to divide by 8 on both sides, and x equals 4. If you check it, you can plug the 4 back into your original equation, original proportion. 4 minus 2 would be 2. So you'd have 2 is to 4 is 4 is to 8. Cross multiply, 2 times 8 is 16. 4 times 4 is 16. We did the math right. The next example is a story problem that's going to use proportions. With an algebra link, or an automotive link, it says, in an engine, the volume of the cylinder changes as the piston moves up and down. The compression ratio is the expanded volume of the cylinder to the compressed volume of the cylinder. One car with a V6 engine has a compression ratio of 9 to 1. So we're going to write 9 over 1 for our first ratio. If the expanded volume of the cylinder is 22.5, find its compressed volume. So we're going to write 9 is to 1 as 22.5 is to x. And how we would know that, as it said earlier, it said the compression ratio is the expanded volume of the cylinder to the compressed volume. Okay? expanded volume to the compressed volume. So 9 to 1. So if the expanded volume is 22.5, what is the compressed volume? So if we write 9 to 1 with expanded volume over compressed volume, we're going to write expanded volume of 22.5 over x, because we want to know the compressed volume, right? We cross multiply 9x equals 22.5, divide by 9 on both sides, and x equals 2.5. So the cylinder's compressed volume is 2.5 cubic inches. So that's an example of a story problem using your proportions and cross multiplication to solve for the unknown. And that's it for lesson 9-1. I would highly recommend you do the check your understanding on page 352 and 353, at least number 1 through 16. You really don't need the braille drawing in number 16, but it's interesting. You can get all the information from the words. For extra practice, you could do number 17 through, you could go all the way to 46, and that would give you lots and lots of extra practice with ratios and proportions. And that would be on page 352 or 353 to 354. So do some good thinking, some extra practice. Make sure you're really good at this particular method of solving proportions and using some basic algebra techniques. And we'll see you in the next video.